Okay, in this video we're looking at Chapter 5. So Chapter 5 is on higher degree polynomials. 5.2 is the one we're looking at, which is quartics, which is powers of 4. So like our other equations for quadratics and cubics, we can say p of x equals ax, and now we'll have powers of 4 plus bx cubed plus cx squared plus x plus c. So that's a general equation for a quartic, or power of 4. Now, just going straight into it, we're going to have a look at the graph of x to the power of 4. So we've got our set of axes, and we're looking for y equals x to the power of 4. Okay, just some little points. Let's go when x equals 1, so 1 and minus 1. So 1 to the power of 4 is going to be 1, and minus 1 to the power of 4 is also going to be 1. Okay, so there's our 2 points to start with. So 1 and 1. Now if we go across to 2, so what happens at y equals 2 to the power of 4? Well, that's going to be 16. And same thing for minus. Okay, because we've got a positive power, we're going to have negatives cancel out. So it's quite large. It goes up to 16 very quickly. So we can say, just kind of connect the points. So it kind of looks like a quadratic at the moment. That's because I'm zoomed in, I guess, in a sense. So if I chose a couple of different points, okay, it actually goes up rapidly a lot quicker. So if I say 1 is about there somewhere, and let's take the point 20, for example. So y equals 20 to the power of 4. Okay, it's going to be extremely large. I don't know why I chose 20. About 16 or 160,000. Okay, so it's going to be right up there somewhere. So what we actually get is a graph that looks something like this, if I can draw it. Okay, basically a quadratic that is flattened. Because if I draw in what a quadratic looks like, actually no, not flattened, the quadratic's flattened. Because the quartic goes up rapidly a lot more. So a quadratic for the same scale would look something like this. Okay, so the quadratic's flattened. This goes up rapidly quite quickly. So this is y equals x squared, and this is y equals x to the 4, or a quartic is what it's called. Okay, similar. So that's just x to the 4. We're not moving up or down or left and right, etc. At this stage, we'll be looking at that soon. So if we have a look at 5.2, we have a key feature table. So I haven't written them out, but if we have a look at the textbook, we've got the graph of y equals ax take h to the 4 plus k has the following features. So again, it looks something that's similar to our turning point form or our point of inflection form. So I've got a turning point with coordinates hk. So if a is greater than 0, the turning point is a minimum. If it's less than 0, it's a maximum. So that's just determining whether it's a minimum or maximum. So axes of symmetry with equation x equals h. So down the middle, we'll have x equals h. It's a similar axes of symmetry. Now it can have 0, 1 or 2 x-intercepts. So quadratic can have 2 x-intercepts. A cubic can have 3 x-intercepts. And a quartic should actually have a possibility of 4 x-intercepts. No, sorry. This is just for this. Okay, forget what I've just said then. We can have 0, 1 or 2 x-intercepts. I'm thinking of something different. So these are obtained with the solution, okay, when we solve it for 0. So if it's in this kind of form, it can have 0, 1 or 2 x-intercepts, similar to our quadratics. Okay, looking at example 1, we're sketching the graph of y equals 1 quarter x plus 3 to the power 4, take 4. Okay, well, from our little summary before, we've got something that looks like y equals a x take h to the 4 take k. So we're going to have a turning point at hk, which is going to be, in this case, minus 3, minus 4. Now, we know that a, in this case, is 1 quarter, so we're going to have a local minimum. So if a is greater than 0, we're going to have a minimum point. So that's the turning point part. Y-intercept is generally easier to find first than our x-intercepts, so that's just finding when x is 0. So 0 plus 3 to the 4, take 4. So we have 3 to the power 4 is 81. Oops. Over 4 from this part, and take away 4. I'm going to say 16 over 4 instead, as a fraction. So we'll have 81 take 16 is 65 over 4. So that's our y-intercept. Not very nice, can't really simplify it at this stage. Now for the x-intercepts, generally a little bit harder to find than our y-intercepts, so that's letting y equals 0. X plus 3 to the 4, take 4. Easiest way is probably solving by adding 4 on both sides. Timesing by 4, so we get 16 x plus 3 to the 4. Okay, the fourth root of 16, well, that's going to be 2. 2 to the power 4 is 16. X plus 3, so x has to be minus 1. Now, what I should have done was plus or minus 2. So we should get minus 1 as one solution, x equals minus 5 as another solution. So there's our 2 points. Okay. Don't forget that plus and minus. Okay, I still make those mistakes.